Welcome to this lesson on solving and writing subtraction equations. Please make sure you have these notes in front of you so we can begin our lesson. This lesson has two learning objectives. The first one says I can solve a one-step subtraction equation, and the second one says I can write a one-step subtraction equation. So let's talk about the inverse of subtraction. Remember, the word inverse means opposite. So the inverse of subtraction, or the opposite of subtraction, is addition. And whenever we solve equations, the overall goal is to isolate the variable. But in order to isolate the variable, we need to use the addition property of equality to keep equations balanced. So let's talk about the concept of balancing. We can assume that our center of our scale is the equal sign, or we call it the fulcrum. So this scale is balanced because we have 3 blocks on each side of our scale. So if I add 2 blocks to one side of the scale, my scale is no longer balanced. So if I add it to one side and I want to keep the scale balanced, we have to make sure we add 2 more circles to the other side of the scale so that we can keep this balanced. This is an example of using the addition property of equality, because if I added 2 circles on one side of my scale, I added it to the other side as well to keep things balanced. So let's use these key concepts to discuss the following examples. So for example 1, it says solve y minus 22 equals 18, and they want us to check our solution. So here's the problem. I'm going to draw my fulcrum, or my dashed line, down the center of the equal sign, because now I have 2 sides to my equation. And remember, the overall goal is to isolate the variable, which is y. But in order to get y by itself, so here's y, let's get it by itself, we need to get rid of our constant, which is negative 22. So in order to get rid of negative 22, I have to do the opposite of minus and add 22. So I'm going to add 22 to the left side of my equation. But I have to keep things balanced, and I have to add it to the other side as well. This is an example of the addition property of equality, because I added 22 to both sides of my equation. So now what I can do on the left-hand side is negative 22 plus 22 goes away, that becomes 0, and I can drop down my variable, and my y is all by itself, which was the overall goal. Drop down the equal sign, and on the right side we can add 18 plus 22, which is equal to 40. So we can check our solution by plugging it back in, or plugging our value of y, which is 40, back into the equation. So 40 minus 22, if we do the math, we will get 18, so we just checked our solution. So once we do that, let's go ahead and graph this on a number line. We know that we're going to place 0 in the center of our number line, and the solution of 40 is in the positive region, so 40 would be about this region right here. And I'm going to identify it with a solid circle, because 40 is the only number that would make this equation true. For example 2, it says solve 9 equals a minus 5, and then we have to check our solution. So here's the problem. Let's go ahead and draw our dashed line, or our fulcrum, down the center of the equal sign. So now we have 2 sides to our equation. And let's start on the right-hand side of the equation, because that's where the variable is at. So I want to isolate the variable of a. In order to do that, I need to get rid of my constant, which is negative 5. So in order to get rid of my negative 5, I have to do the opposite of negative 5 and add 5. So I'm going to add it to both sides of my equation. So this is an example of the addition property of equality, because I added 5 to both sides of the equation. So now what I can do is subtract, or negative 5 plus 5 goes away, that becomes 0, and I can drop down my variable, which is now isolated, drop down the equal sign, and on the left-hand side, 9 plus 5 becomes 14. So now let's check our work by plugging 14 back into the equation. If I do 14 minus 5, and I do the math, I do get 9, so I've just checked my work. Now let's go ahead and graph our solution. 0 would be placed in the center of our number line, and since we're talking about positive 14, it's going to go on the right-hand side of 0, so positive 14 is here, and I'm going to identify it with a solid circle, because 14 is the only number that would make this equation true. So pause the video and complete these got it problems, and we'll discuss the answers in class tomorrow. Notice I have 2 got it problems on this slide, got it problem A and got it problem B, and please be sure we graph each of our solutions. For example 3, it says solve 22 minus y equals 18, and then let's check our solution. So this problem is a little different. We're still going to start off with drawing our fulcrum down the center of our equal sign. But now, if you look at it, our variable has a minus sign or a negative next to it. Anytime that your variable has a negative sign next to it, let's get rid of that negative sign by doing the opposite of minus y. So if I want to do the opposite of minus y, I have to add y to both sides. This is an example of the addition property of equality. So notice on the left hand side, negative y plus y, that's going to go away, and 22 will be by itself, equal to 18 plus y. So now if you think about it, this looks like the same type of problem that we solved in the last video lesson. Let's go ahead and isolate the value of y, or our variable, by getting rid of the constant, and the constant is this positive 18. So let's subtract 18 on both sides, subtract 18 on both sides on that side. This is an example of using the subtraction property of equality, because we subtracted 18 on both sides. So on the right hand side, 18 minus 18 goes away, and we can drop down our y, so now our variable is isolated, and 22 minus 18 becomes 4. So our answer is 4. Let's plug it back in to see if this makes sense. 22 minus 4, and when we do the math, we do get 18, so we checked our solution. Now let's go ahead and graph our solution on the number line. Let's place 0 in the center, and positive 4 will go around here, and I'm going to identify it with a solid circle, because 4 is the only number that will make this equation true. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. Notice I have one got it problem on this slide, and I'm asking you to graph the solution as well. Example 4 says Pete is 15 years old. This is 6 years younger than his sister Victoria. Write and solve a subtraction equation to find Victoria's age. So let's use variables to identify the names of the people in this problem. P will stand for Pete, and V will stand for Victoria. If we start by reading the second sentence, it says Pete is 6 years younger than his sister Victoria. If I write it the way I see it, I can say 6 minus V. However, the word than is a taffy word, which means we need to flip. So we would actually write it as V take away 6. And this would equal Pete's age. So Victoria take away 6 years will get you Pete's age. And the reason why we're using subtraction is because it says younger than. So if it says younger than, we're going to assume that we're subtracting or taking away. So now what we can do, since we have this equation, we can use this equation to solve for Victoria's age. So let's draw the fulcrum down the center of the equal sign. And I'm going to isolate my variable by starting on the left-hand side. And I'm going to add 6 on both sides of my equation. That's an example of the addition property of equality. We're going to cross out negative 6 plus 6 to get 0. And let's drop down our variable, which is V. And on the right-hand side, we're going to add 15 plus 6, which is equal to 21. So Victoria is 21 years old. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. Notice the problem says write and solve a subtraction equation. So now that we've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.